Good afternoon, students. In the last class, we were discussing about the chemical characteristics of wastewater. Okay, so we have covered till sulfates. All right, and there are some chemical characteristics which are left. Okay, so I have given you some notes. I think on Saturday. Okay, you just go through the notes of chemical characteristics, and on Monday, that is yesterday, I have also given you the remaining chemical characteristics as well as the biological characteristics for wastewater. Okay, but in the sulfates, the sulfate which falls under the chemical characteristic. Okay, so there are some chemical characteristics which are left. Okay, those are your dissolved oxygen, your BOD, that is biochemical oxygen demand, and chemical oxygen demand. So in this lecture I'll be discussing about the dissolved oxygen, and then I will go to the biochemical oxygen demand, because biochemical oxygen demand and chemical oxygen demand are the two most important parameters, okay, to measure the pollution level, and these will be explained in detail. And you also have practicals regarding BOD, okay, and you have practicals regarding COD and also dissolved oxygen. Okay, so we'll start with this lecture, okay, with dissolved oxygen. Okay, so what is dissolved oxygen? Dissolved oxygen, in simple words, is the amount of oxygen which is in dissolved state in wastewater. Okay, dissolved state, by dissolved state I mean is that it is the free oxygen, okay, which is O2, okay, free molecular oxygen. All right, okay, amount of dissolved amount of oxygen in dissolved state in wastewater is called as dissolved oxygen. So dissolved oxygen is abbreviated as DO. Okay, all right, and also it indicates pollution. Okay, so dissolved oxygen indicates pollution in your sample of water or wastewater. How? This I will cover in the BOD part. Okay, this I will cover in the BOD part, how and why this dissolved oxygen content is used as an indicator for pollution. Okay, all right, so moving on. Minimum DO. Okay, so next point is minimum DO must be 4 mg per liter or 4 ppm. That means minimum DO in any sample of water or in any river, it has to be 4 mg per liter. Why? Because if your DO falls below 4 mg per liter, your aquatic life will be hampered. That means this I am writing here. Okay, if DO falls below 4 ppm, then aquatic life will be hampered or will be damaged. Fishes, for survival of aquatic life, for survival of fishes, the minimum DO requirement is 4 mg per liter. Okay, so this you remember, this is very important. All right, okay, next is temperature is a very important factor in the solubility of oxygen in wastewater or water. Okay, so that how, see, there are three main factors which will which are the most important parameters for your solubility of oxygen in water. Okay, the three factors on which DO depends on. Okay, so factors on which DO depends are: first is your temperature. Okay, first is your temperature. What is the significance of temperature with DO? It is when they are inversely proportional. Okay, always remember, temperature and DO are inversely proportional. That means when temperature increases, dissolved oxygen in water decreases. Okay, so the amount of dissolved oxygen in water decreases. Okay, so temperature is inversely proportional. Okay, the second factor is salinity. Salinity means presence of ions like sodium chloride, magnesium chloride. Okay, for example, seawater is saline in nature. Okay, so the DO also depends on the salinity of water. Okay, how? See, DO decreases exponentially. DO decreases exponentially with respect to salinity. Okay, DO decreases exponentially with respect to salinity. Okay, if salinity increases, okay, if salinity increases, then DO will decrease. How? Exponentially. Okay, DO will decrease exponentially. Also, important information for you: note, at same temperature and pressure, seawater holds 20% less dissolved oxygen than fresh water. Than fresh water. Okay, see, at same temperature and pressure, seawater holds 20% less DO than fresh water. Okay, so that means salinity is a very important factor for your dissolved oxygen. Okay, so students, you can pause the video here and you can note it down. Okay, so since it's a video, so you can pause it and you can note down these things. Okay, these things are not available in your writing in your notes. Okay, so always you must study. Whenever you want to study completely, you must refer your textbooks, you must refer your class lectures, and also you must refer the notes that is given to you. With this combination of these three will result in the complete preparation for your examination in any subject. Okay, so you can pause the video and you can note it down. Okay, okay, so temperature is the first important factors, and second is salinity. Okay, and third is pressure. Okay, let me clear this part. Third is your pressure. Okay, just a moment. Okay, so third most important point or important factor is your pressure. Okay, So how pressure is related with DO? Okay, pressure is directly proportional to the amount of DO. That means if pressure increases, dissolve amount of dissolved oxygen will also increase. Okay, so third is your pressure. How pressure is related? Pressure is directly related. Okay, if pressure increases, it is directly proportional. Okay, if pressure increases, amount of dissolved oxygen also increase. Okay, and this pressure that I'm writing here, this pressure is for both atmospheric and hydrostatic. Okay, so this pressure is both atmospheric and hydrostatic pressure and hydrostatic pressure. Okay, so if pressure, that pressure can be both atmospheric pressure and hydrostatic pressure. Okay, so if pressure increases, your DO also increases. Okay, and you can take an example. DO level in lower altitude is obviously and always higher than DO at higher levels. Okay, so if you have two rivers, one river is flowing in a lower altitude and another river is flowing in a higher altitude, then dissolved oxygen of river that is flowing in the lower altitude will be always higher than the dissolved oxygen amount in the river that is flowing in higher altitude. Okay, all right, so we'll moving on to the next topic. Okay, now types of oxygen demand. Okay, so what is an oxygen demand basically? Okay, see, let's take an example. You want to buy a mobile phone. Okay, so what do? You go to your parents and you demand money, right? I think everyone does that. So you go to your parents and you demand money, and you get the money and you buy a mobile phone, right? So like that, there is a demand of oxygen. Okay, now where there is a demand of oxygen, slowly you will learn. Okay, slowly you will learn where there is a demand of oxygen, but generally oxygen is demanded in wastewater for oxidation. Okay, why oxygen demand is there? Oxygen is demanded in wastewater. Oxygen is demanded in wastewater for oxidation. Okay, this is most important, for oxidation of what? Oxidation of organic as well as inorganic matter. Oxidation of organic as well as inorganic matter. Okay, so that is your oxygen demand. Okay, now there are four different types of oxygen demand. One is biochemical oxygen demand, in short it is called as BOD. Next is your chemical oxygen demand, in short it is called as COD. Then total oxygen demand, it is called as TOD. And last is your theoretical oxygen demand, also called as THOD. Okay, so these are the most important types of oxygen demand. All right, Okay, so we will start, or we will focus on the BOD in this class. Okay, so moving on. So what is biochemical oxygen demand? Okay, so there are definitions, your notes are given to you, so you can just go through your notes. Okay, but before knowing a definition, you must understand the basics of that. Okay, so here in this class we'll cover that, the basics. Okay, so what is BOD, and with that there are some formulas and numericals will also be there. Okay, so always remember some important points. Okay, there is there are okay, in your wastewater, okay, there are bacterias. Okay, so in your wastewater there are bacteria. So what is the types of bacteria there are what are the different types of bacteria which are present in the wastewater? They are of three types. Okay, I think you know. One is aerobic, anaerobic, and last is facultative. Okay, facultative. So these are the three types of bacteria present in your wastewater. Okay, now what are aerobic bacteria? Aerobic bacteria are those bacteria which require oxygen, that means free oxygen. Okay, anaerobic bacteria are those bacteria which can survive without oxygen. Okay, and facultative bacteria are those bacteria which can survive in both aerobic environmental condition and in anaerobic environmental condition. Okay, so they can survive in both. Okay, so now bacteria is always present in your wastewater. Okay, so bacteria are the most important thing for the treatment of wastewater. Okay, important living organisms. Okay, so now what is the sole purpose? I have discussed it in the class. Okay, if you remember, what is the sole purpose of a bacteria? Okay, what a bacteria does? A bacteria eats. Okay, a bacteria eats. What it eats? A bacteria, wait, sorry, a bacteria eats and a bacteria multiply. Okay, that means they reproduce. A bacteria eats and a bacteria reproduce. Okay, what does a bacteria eat? Okay, what does a bacteria eat? Bacteria eats wastewater. Okay, bacteria in general, they eats waste water. Okay, now to go in detail. Okay, so I'm now going in detail step by step. Okay, how many types of bacteria are there? Three types: aerobic, anaerobic, and facultative bacteria. Okay, so what are the two most important goals in the life of a bacteria? It is to eat and to reproduce. Okay, what the bacteria eats? The bacteria eats the wastewater. Okay, now I'm going into the wastewater. Okay, so the bacteria cannot eat wastewater, right? So it has to eat something which is present inside the wastewater. Okay, so bacteria eats wastewater, but it eats, actually, if you want to, if I'm taking a point here, I want to clarify it little bit. The bacteria eats something which is present inside the wastewater. Rather, that will be a very good point. Okay, so bacteria eats something which is present inside the wastewater. So what is present inside wastewater? So inside wastewater there are organic impurities, inorganic impurities. Okay, And your organic impurities can be divided into two. One is biodegradable and one is non biodegradable. Okay, so there are organic impurities and inorganic impurities, okay, which makes, or there are any, also there are several other impurities like suspended solids and all those, but chemically if you see all the impurities of wastewater, they are chemically, they can be classified into two. One is organic and one is inorganic. Okay, so under organic impurities there are two types. One is biodegradable organic impurities and one is non biodegradable organic impurities. Okay, so now I am again going to that question, what a bacteria eats. Okay, I'm going to this question, what a bacteria eats. A bacteria eats something which is present inside the wastewater. We know that inside wastewater there are organic and inorganic impurities. Okay, so now the bacteria can eat, or bacteria eats organic impurities, okay, which is biodegradable. Okay, so bacteria cannot eat inorganic impurities, or bacteria cannot eat organic impurities which are non biodegradable. Okay, so bacteria can only eat and oxidize the biodegradable part of organic waste or organic impurities. So this is the most important point. Okay, so the bacteria present in the wastewater can only eat and oxidize the biodegradable part of the organic impurity. Okay, okay, so I'll write in a different page. Obviously you can pause the video, you can write it down. See, bacteria can oxidize, okay, oxidize the biodegradable organic waste. Okay, so inside the wastewater you have different waste, one is organic, one is inorganic. So in inorganic waste also you have biodegradable and non biodegradable, but bacteria can only eat the biodegradable organic waste. Okay, and not the non biodegradable organic waste. Okay, so I think till this point you were clear. Okay, now though bacteria can eat the biodegradable organic impurities, what happens is that the important thing is dissolve oxygen. Okay, so what happens is that since there are aerobic, anaerobic and facultative bacteria, so what happens for oxidation? Okay, for oxidation of wastewater waste in wastewater, for oxidation of waste in wastewater, okay, sorry, okay, I think it is gone. Okay, let me write again. For oxidation of waste in wastewater, okay, for oxidation of waste in wastewater, see the word oxidation. Okay, I have written the word oxidation, hence what you need, hence oxygen is required. Okay, so for oxidation of wastewater, oxygen is required. So how this oxygen is coming? This oxygen that is required, the bacteria are obtaining this oxygen from the dissolved oxygen present in the wastewater. Okay, so that is how dissolved oxygen is important. Okay, so bacteria oxidizes the waste inside the wastewater. How the oxidation is taking place? The oxidation, obviously, with the word oxidation you need oxygen. Okay, so there is a need or requirement of oxygen. Okay, how this oxygen is obtained? This oxygen is obtained from the dissolved oxygen which is present in your wastewater. Okay, so everything is connected with the dissolved oxygen. Okay, so if there is no dissolved oxygen, hence there will be no oxidation. So no DO, no oxidation. Okay, so if this case arises, if this case arises, let's say if you don't have dissolved oxygen inside your wastewater, then there will be obviously no oxidation. In that case, in this case, waste will be decomposed by anaerobic bacteria. Okay, so in this case your anaerobic bacteria will come into play. Okay, but if it has dissolved oxygen, then your aerobic bacteria will come into play. Okay, aerobic bacteria. Okay, so I hope it is clear till this point. Please follow with the lecture. Okay, and if you have any doubts, you can ask me in the concerned group. All right. Okay, you can just go through it once, or you can pause the video and you can go through it. Okay, so I'm recalling it once again. So there are impurities in wastewater. Okay, so you have different types of bacteria. One is aerobic bacteria, one is anaerobic, and one is facultative. Okay, so what the bacteria does, a bacteria eats and reproduces. Two things the bacteria does: it eats, or it oxidizes, and it reproduces. Okay, so now what a bacteria eats in wastewater? So inside wastewater there are organic and inorganic impurities. Okay, so a bacteria will eat organic impurities. Okay, but it cannot eat all the organic impurities. It can only consume the organic impurities which are biodegradable. Okay, so there are two types of organic impurities. Again, under organic impurities you have two types of organic impurities. One is biodegradable organic impurity, one is non-biodegradable organic impurity. So the bacteria can only oxidize the biodegradable organic impurity. Okay, hence now since it can oxidize the biodegradable organic impurity, therefore for oxidation of waste in wastewater, bacteria will utilize oxygen. Okay, bacteria will utilize oxygen. So how they are getting this oxygen? They are getting this oxygen from the dissolved oxygen that is present in the wastewater. Okay, so in this case your aerobic bacteria is taking this action. Everything is done by aerobic bacteria and also facultative bacteria. Okay, because facultative bacteria can survive in both aerobic and anaerobic condition. Okay, now if the case is that if there is no dissolved oxygen left in your wastewater, hence obviously there will be no oxidation. So in this case your waste will be decomposed by anaerobic bacteria. Okay, so in this case there will be no aerobic bacteria involved, only anaerobic bacteria will be involved. Okay, and obviously facultative bacteria which operates anaerobically. Okay, so these bacteria will be involved if there is no DO left. Okay, I hope it is clear till this point. Okay, so how the word demand is coming? Okay, so we are studying under oxygen demand, right? So this everything is coming under oxygen demand. Okay, so how the word demand is coming? Okay, so BOD is what? BOD is biochemical oxygen demand. Okay, so now you understand the terms. So how this oxygen demand is coming? Okay, so how oxygen demand is coming? Oxygen is demanded. Okay, oxygen is demanded by the bacteria to oxidize biodegradable organic waste. Okay, so oxygen is demanded by aerobic bacteria to oxidize biodegradable biodegradable organic waste. Okay, so that is how the word oxygen demand is coming. Okay, so the bacteria, mostly your aerobic bacteria, will demand oxygen. Okay, since aerobic bacteria, main purpose of bacteria is to eat what? Eat the wastewater. What inside the wastewater they will eat? They will eat the biodegradable organic waste. Okay, so to eat or to oxidize biodegradable organic waste, you need oxygen. Okay, you need oxygen. Okay, so hence the bacteria will demand oxygen from the wastewater to oxidize the biodegradable organic waste. Okay, clear? Okay, I hope it is clear till this point. Okay, also BOD, that is biochemical oxygen demand, was previously called as biological oxygen demand. Biochemical oxygen demand was previously called as biological oxygen demand. Okay, but nowadays it is not called as biological oxygen demand, rather it is called as biochemical oxygen demand. Okay, why the word is changed? It is because bio, see I am breaking this word biochemical. Okay, let me write it properly. Biochemical. So it comprises of two words. One, right? One is bio, one is chemical. Okay, so why two words are used? See, bio means the living organisms, the living organism. So in this case it is bacteria, the living organism is bacteria. And why the word chemical is used? The chemical is used because these reactions to oxidize the waste are are chemical based. Okay, so some chemistry is involved, right? So these reactions for oxidation, these reactions to oxidize the waste chemical reactions are taking place. Okay, chemical reactions are taking place, though though these chemical reactions are brought about by the bacteria, which is living organisms, okay, yet these are chemical reactions, okay. That is why nowadays biological word is not used, instead it is biochemical word that is more suitable, okay. So that is why this is changed from biological oxygen demand to biochemical oxygen demand, okay. All right, so I hope everyone is following till this point, okay. So we are moving to the next uh, segment of this topic, okay. Now, stages of BOD. Stages of BOD. Okay, so there are two stages of BOD. Okay, there are two stages of BOD. One is first stage, BOD, or carbonaceous BOD, or carbonaceous BOD, okay. This is called as, sometimes called as CBOD also, okay. There are two stages of BOD. First is your first stage BOD, also called as carbonaceous BOD or CBOD in short. Second stage BOD or nitrogenous BOD, also abbreviated as NBOD, okay. So there are two stages of BOD. One is first stage BOD or carbonaceous BOD, also called as CBOD, or second is second stage BOD, also known as nitrogenous BOD, okay. So these are the two different stages of BOD, okay. So there is a graph also, so let me draw the graph, just a moment. Okay, so let's say all right. So in the x-axis it is time, in the x-axis it is time in days, in y-axis it is oxygen demand, in y-axis it is oxygen demand in milligram per liter. Okay, all right. Now this is divided. Okay, let's say this is 2, 4, 6, 8, 10. Okay, like that. This is 2, 4, 6, 8, 10. Okay, and then if you draw a graph, so a graph comes out to be something like this. Somewhere here there will be a day 5. Okay, so let me extend this. Okay, so okay, so this part is first stage. This is your carbonaceous BOD. This is your second stage or NBOD, nitrogenous BOD. Okay, and this is called your total BOD. Total BOD. Okay, so this is your 5 days. All right. Okay, so you can look into the diagram. So what the diagram is explaining also. Okay, I'll just come little bit back to the diagram. Okay, so what the diagram is explaining, see, at this point, okay, this is 0. So in x-axis you have days, time in days, and y-axis you have oxygen demand. Okay, I think you are clear what is oxygen demand. Okay, I have already explained it. So now what happens, there is a sample of wastewater. Okay, so at day 0 there is no oxygen demand. Okay, there is no oxygen demand, so at day 0 it is 0, oxygen demand is 0. As the time increases in x-axis, the oxygen demands also increases in y-axis. Okay, so as the time goes on increasing from day 0 to day 5, okay, your corresponding oxygen demand also increases, okay, up to a certain value, and then this curve stabilizes. Okay, so almost flat plateau is obtained here. Okay, and then you can see there is one more curve that is generating from this point, and it goes on like this. Okay, alright, now what this graph is signifying, okay, this graph is showing the stages of BOD. One is first stage BOD, one is second stage BOD. What is first stage BOD? First stage BOD is also called as carbonaceous BOD. Okay, so what is carbonaceous BOD? Carbonaceous BOD is the oxygen demand by the bacteria to oxidize the compounds which are carbon based. Okay, that means, see, go to a new slide. Now bacteria oxidizes biodegradable organic waste, right? So biodegradable organic waste is there. Now what happens, biodegradable organic waste is of two types. One is carbon based one is carbon based, and one is nitrogen based. Okay, so biodegradable organic waste is of two types, one is carbon based and one is nitrogen based. Okay, so bacteria will oxidize both this carbon based and the nitrogen based, but their time required is different. Okay, to oxidize the carbon based biodegradable organic compound, biodegradable organic waste. Okay, now I am focused into the carbon based. So for bacteria to oxidize the carbon based biodegradable organic waste, it takes around 5 days. Okay, it takes around 5 days for 60 to 70% oxidation. Okay, and 95% oxidation in 20 days. Okay, so for bacteria to oxidize the carbon based biodegradable organic waste, okay, so 5 days are required to oxidize 60 to 70% of carbon based biodegradable organic waste. Okay, and it takes 20 days to oxidize 95% of carbon based biodegradable organic waste. Okay, is it clear? So from day one, so if I look into the graph again, okay, so CBOD means carbonaceous BOD. Okay, so in this stage only carbon based organic compound is oxidized. Okay, so this stage is oxidation of carbon based organic compound, organic waste. Okay, so the time required by the bacteria to oxidize the carbon based biodegradable organic waste, okay, and the oxygen that is demanded during this stage is called as the first stage BOD or CBOD. Okay, now what happens? See, I have written here 1.5 days. Okay, so what happens to nitrogen based organic compound? Okay, so for nitrogen based organic compounds, okay, oxidation of this type of compounds, okay, oxidation of nitrogen based biodegradable organic waste, okay, oxidation of nitrogen based biodegradable organic waste starts from day 6 to day 10. Okay, this process is called as nitrification. Okay, process is called as nitrification, is called as oxidation of nitrogen based organic compounds is called as nitrification. Okay, see, most important point, oxidation of nitrogen based biodegradable organic waste starts from 6th day to 10th day. Why? See, because nitrification, okay, the bacteria which does nitrification is called nitrifying bacteria. Okay, so the bacteria or the group of bacteria which is responsible for nitrification are called as nitrifying bacteria. Okay, let me write somewhere here. Okay, nitrifying, just a moment. Let me rub this one. Okay, so I'm connecting this one. Okay, so the bacteria which is responsible for the process of nitrification is called as nitrifying bacteria. Okay, so the nitrifying bacteria, they grow, or their growth rate is very slow. Okay, the growth rate of nitrifying bacteria is very slow. Okay, hence the nitrifying bacteria does not grow in large numbers. Okay, so you go to this graph again, see, from day 0, let's say day 2, day 4, day 5. Okay, so the growth rate of nitrifying bacteria is very slow, and only nitrifying bacteria can do nitrification. Okay, hence, since the growth rate of nitrifying bacteria is very slow, hence their oxygen demand is not visible from day 0 to day 5. Okay, during this span from day 0 to day 5, the oxygen demand by the nitrifying bacteria is not visible as per the graph. Okay, why it is not visible? Because there are not sufficient amount of nitrifying bacteria present in wastewater. Why there is not sufficient amount of nitrifying bacteria in wastewater? It is because it takes time for the nitrifying bacteria to grow. Okay, their growth rate is very less. Okay, so that is why from day 6 onwards, okay, the growth of nitrifying bacteria increases. Okay, so that is why after day 5, okay, after day 5, you see there is a second graph which is growing. Okay, so this is indicating that your nitrifying bacteria is now demanding oxygen. Why it is demanding oxygen? It is demanding oxygen to oxidize the nitrogen base, to oxidize the nitrogen based organic compounds. Okay, nitrogen based organic waste. Okay, so that is why after day 5 suddenly there is a second graph which is increasing. That means there is a oxygen demand which is coming after day 5, and this oxygen demand is coming because of oxidation of nitrogen based biodegradable organic waste. Okay, and the bacteria which is responsible for this demand is the nitrifying bacteria. Okay, and their numbers increases only after day 5. Okay, that is from day 6 to day 10 their number increases, but before day 5 their quantity was very less, and that is why they don't exert any oxygen demand. Okay, from the wastewater or from the environment of the wastewater. Okay, I hope this is clear till this point. Okay, and there is one more thing I forgot to mention in this diagram. Okay, so I'll write it down, please note it down. First let me rub this part little bit, it will confuse you. Okay, so I'll draw it. Okay, I'll draw it. Okay, so you see from here this graph can also go like this. Okay, see the black dotted lines. Wait, Okay, so from here the black dotted line can also go like this. Okay, okay, so what is this actually? So this part, okay, the black dotted lines, so it's continuing from this. Okay, it's continuing from the first stage BOD, but it is not going taking this turn, it is rather it is directly connecting here. So significance of this is if sufficient. Okay, so your graph may not be always in this shape. Okay, so I'll write it in a different slide if it will be clear for you. Okay, so this is your graph, this is time, this is oxygen demand, okay. So sometimes what may happen is that from this point the graph can be like this also. Okay, why this is the case? It's not always, it can be sometimes. Why? If if in any case you are getting this graph, okay, this dotted line graph instead of the red line graph, which is generally the red line graph you will observe. Okay, but sometimes you may observe this and this red line along with the dotted line. Okay, along with the dotted line means the graph will continue in this way. Okay, if you are getting this type of graph, hence it will signify that there are there are sufficient there are sufficient number of nitrifying bacteria. So if sufficient amount of nitrifying bacteria is present in your wastewater, okay, then nitrification will occur from the fifth day itself. Okay, this is day 5. The nitrification will occur if there are sufficient number of nitrifying bacteria in your wastewater. Then nitrification can take place from day 5 onwards. Okay, in that case you will get a graph like the dotted curve. Okay, also nitrification generally occurs after day 5, but if it is the case where there are sufficient nitrifying bacteria in your wastewater, then you may get instead of this red line you may get this. Okay, so your graph will continue like this and it will not turn this side, rather it will go towards this side. Okay, one half will turn this side for the CBOD. This is your CBOD and this is your NBOD. Okay, instead of going this side, so it will now go this side. Okay, if there are sufficient nitrifying bacteria present. Okay, I hope this is clear till this point. All right, okay, so there are some numericals also we will do, but I think this is already being very long lecture. I hope you are not bored with this lecture. Okay, so today we will not be able to complete the numericals, but at least the theory part will complete. Okay, so let me clear everything. All right, so now most importantly, okay, so some note for you. Number 1, BOD test is carried out BOD test is carried out for 5 days at 20 degrees Celsius. Now you will ask me why at 20 degrees Celsius and that too for 5 days. It is because there is a reason behind that. Okay, it is because theoretically BOD is a test which takes infinite time. Okay, so theoretically BOD is a test which takes infinite time to complete the oxidation of carbonaceous material. Okay, but we cannot wait that long. Okay, also theoretically, I'll write it down. Theoretically, it takes infinite time to oxidize carbonaceous matter. Okay, so that we cannot wait that long. Okay, also 20 days, also at 20 days 95 to 99% of original waste is oxidized. Okay, so 20 days, a test to be conducted for 20 days is also very high. Okay, though 95 to 99% of your original waste is oxidized completely, yet 20 days is a very long time. Okay, so we cannot wait 20 days for a test to be completed. So what we do at 5 days, okay, at 5 days around 60 to 70%, okay, to be precise it is 68%. Okay, precisely it is 68%. So at 5 days around 68% of original waste is oxidized. Okay, so at 5 days, okay, 68% of your original waste is oxidized. So this is your carbonaceous, okay, not the nitrogenous. Carbonaceous waste. Okay, so because at 5 days nitrification has not started yet. Okay, so only the carbonaceous waste. Okay, so at 5 days around 60 to 70, to be precise it is 68% of the original waste is oxidized. Okay, so hence we take 5 days as a standard time for the determination of BOD of a given sample of wastewater. Okay, and that test is done at the 20 degree centigrade. Okay, so there is one more reason I will tell you why. So in England, okay, so this is the scientific way why we are doing. Okay, but there is one more, actually how this concept started. This concept started in England. Okay, so the concept of BOD started in England. Okay, so there is one actual reason why it was selected for 5 days at 20 degrees Celsius. So there is a commission, okay, in England, that is Royal Commission on Sewage Disposal. Royal Commission on Sewage Disposal Royal Commission on Sewage Disposal proposed initial BOD standards. Okay, so they, what they did, they proposed initial BOD standards. So accordingly, what happened is that there is a river in England called as Thames River. Okay, so there is a river in England called as Thames River. Thames River. Okay, so the Thames River took 5 days from its origin to join sea. Okay, so originally this idea was all the BOD standards were given by the Royal Commission on Sewage Disposal. Okay, so Thames River that is present in England, it takes 5 days to travel from its origin to join the sea. Okay, and the temperature of the Thames River was 20 degrees Celsius average temperature. Okay, so hence 5 day was considered as a standard period. Okay, hence because of this 5 days were considered as a standard for the BOD test. So this was a history that I informed to you, but nowadays this is because of this reason. Okay, this is 5 days is because of this 68% of the carbonaceous waste is oxidized. Okay, and hence 5 days, in 5 days, so it is taken as 5 days. Okay, but original reason for giving the BOD standards, okay, was given by Royal Commission on Sewage Disposal, and they gave it for 5 days because the Thames River took 5 days from its origin to join the sea. So these are the reasons why the BOD test is done for 5 days. All right. Okay, also I will write one chemical reaction. Okay, how the oxidation takes place. So oxidation for BOD. Okay, so this is for BOD. So you have bacteria plus biodegradable organic waste plus dissolved oxygen will give carbon dioxide, water, and new bacterial cells. Okay, so more bacteria is being produced. Okay, so more bacteria is being produced plus stable end products, since this is aerobic oxidation, so stable end products. Okay, stable end products, and this is oxidation. This is the complete reaction, okay, by the aerobic bacteria. Now in case of nitrifying bacteria, for nitrifying bacteria, for them how the reaction take place, you have nitrifying bacteria organic matter. So what is the organic matter which is oxidized by nitrifying bacteria? It is ammonia nitrogen. Okay, so it is ammonia nitrogen. So this ammonia nitrogen is converted to nitrites first and then to nitrates. Okay, so this is your nitrite E, and this is your nitrate, stable end product. Okay, so this is your first equation is a general oxidation reaction, and second reaction is for specifically for the nitrifying or nitrification process. Okay, alright, so we have completed the theory part till here. Okay, so after that, the next lecture we will be solving some numericals based on the determination or the test of BOD. Okay, and then we will again go for some derivation of the first stage BOD equation formulation. Okay, so there are some chemical there are some reactions, okay, equations, sorry, there are some equations, so we'll derive those equations and then we'll go for the numericals. Okay, so I hope everyone has understood till this point. If you have any doubts, obviously you can ask me in your concern group. Okay, and do keep studying. You always, okay, you must follow your video lectures, so all the important topics will be covered through your video lectures, and remaining parts, the topics, okay, which are theoretical, I'll provide you notes for that. And if you find any difficulty in those topics, then I can go for video lectures also in those topics. Okay, so with that said, do watch the video. Okay, do watch this lecture, and if you have any doubts, you can note it down and you can ask me in the concern group. Okay, also you take your notes and you go through your notes and you study. Okay, don't miss your studies. You should not hamper or you should not waste time. Okay, so you should study, though it's lockdown, you should always be focused on your studies. Okay, with that said, thank you for your patience. We'll meet you in the next class. Okay, thank you.